Recording has started. Okay, so good morning, everyone. Welcome back to Math 115. I'm glad to hear you're all so lively this morning. Maybe it's because the weekend's coming up, or it's excitement for the quiz today. So before we do the quiz, we're going to have our normal lecture. It'll be cut short by about 17 minutes to give me enough time to pass out the quiz. So what we're going to talk about today is more of 1.3, which we barely started last time. And we're also maybe going to touch into section 1.4. So I'd like to remind you about two homework assignments that you have, one of which is due today, that is 1.1. And let me update that there. So 1.1 is due today at 11:59 p.m. And 1.2 is due on Sunday. I was going to have it due tomorrow, but I figured why not give you a couple extra days. So it can be due on Sunday. The next quiz is going to be the quiz that we have today. Okay, so that quiz is going to cover sections 8.4, 8.6, and 8.7. I think if you came to office hours, you'll probably have a large benefit on that quiz. So I highly recommend coming to office hours to study for the quiz, because we talked about a lot of the topics that are going to be on the quiz today in office hours on Tuesday. So speaking of office hours, I will have office hours again today from 2:30 to 4 in my office, LeConte 439. Be advised, it's very cold in that building. Any administrative issues before we start in on content for today? All right, doesn't seem like there's any administrative questions, so let me remind you what we talked about last time. So last time we started by talking a little bit more about circles. So we had already seen the standard form of a circle, okay, with center at h comma k and radius r, is given by this equation, which looks like the Pythagorean theorem. Why? Because inside of any triangle, or of any circle, we can always draw a triangle. That's the coolest fact I know about triangles, is that you can draw them whenever and wherever you want. So in this case, we draw them inside of a circle, and that's how we get the Pythagorean theorem to show up for the equation of a circle. So then we talked about completing the square, which was, okay, suppose I had an equation which I'm told does represent a circle, but it doesn't look like that standard circle form. So we learned how to convert between the two by completing the square. And completing the square was this really tricky thing where we temporarily make the equation more complicated than it was before by adding something and subtracting something. Okay, so if I add and subtract, then I haven't changed anything. But since I have this additional term here, I can go ahead and factor this three-term subpiece of our equation and get a perfect square. Okay, so that's by design. We pick b over 2 and we square it. We add and subtract that number in order to be able to complete the square. So that was how we transformed the equation of a circle, which was in general form. Okay, we then completed the square twice, moved over the additional extra terms, and then we had an equation which looked just like the equation of a circle in standard form. So that was about how do we tell where the center is, how do we figure out what the radius is, and how do we draw this thing if it's not in standard form. We have to convert it first. Any questions at all over circles? The equation of a circle in standard form or general form or converting between the two? Okay, seems like that's pretty clear. If it's not clear to you, then I recommend coming to office hours today at 2:30 p.m. All right, so then we had another practice, and then we started in on 1.3. So for 1.3, we just barely started talking about lines. So lines in the plane, okay, are essentially determined by their steepness and a point that they pass through. Okay, so if we can say, well, it passes through this point and it has this steepness, then we can uniquely identify a line. We'll talk more about that in a second. But the first thing we wanted to do was say we do find ourselves with a line in the coordinate plane. How do we figure out what its steepness is? Well, the steepness of that line is what we call the slope, and it's given by taking the rise over the run. So what do we do? Like always, our favorite thing to do in this class is to draw triangles where there wasn't a triangle before, and then we measure the height of the triangle, namely this piece, which is y2 minus y1, or the rise. And then we measure the width of that rectangle, which is, of course, the run. And then this is how we get rise over run, which is given by the formula y2 minus y1 over x2 minus x1. And we also learned that if we permute the order of the numerator and the denominator, then we're going to get the same thing, because I'll just introduce an extra negative on the bottom and on the top, and two negatives, if they're on the bottom and the top, are going to cancel each other out. So that was about the slope of a line. And the last thing that I think I said was is how to identify positive and negative slope visually. Well, if we have a positive slope, then that means exactly what you think it means. It means that the number m, which we use to describe the slope, i.e. the rise over the run, is a positive number. Okay? And a positive slope means that the line increases from left to right. So the way we think about that is, if I was a little person here and I was going to walk in this direction, I ask myself, will I be walking uphill or will I be walking downhill? Okay, if I'm walking uphill, then we have a positive slope. If I'm walking downhill, then I have a negative slope. Okay, so that was where we left off. Before we move on to talk about a bunch of equations of lines and point slope form and slope intercept form and general form of lines, are there any questions over the basic notion of slope? Okay, seems like not, so let's talk then about the slope and the form of a vertical line. Okay, so these ones are a little bit tricky, okay, when we have the vertical lines or the horizontal lines. But hopefully this will clear that up for you all. So two types of lines, one of which goes left to right and one of which goes up and down. Which one is the vertical line, up and down or left and right? Yeah, vertical means up and down. Okay, so vertical line looks like so, maybe. So the vertical line can be seen here. Okay, and we want to ask ourselves, well, sorry, was there a question? Oh. Okay, so we want to ask ourselves, what is the slope of this guy? Okay, that's easy enough. Well, we just have to take 2 points on this line, right? We have to take 2 points on this line. But the interesting thing about a vertical line is, let's check what are the points going to be. The first one, we'll call it x1, y1, right? And then the second one, I would say that it's x2, y2, except what? The x value of these 2 points is the same. Do you agree with me? Because we go this much to the right and then this much up, or for the other one we go the same amount to the right and a little bit more up. So the y values are different, so I'm going to do y2, but I'm going to repeat. I'm going to put x1 here again, okay, because it's the same x value for both of them. Okay, so what am I supposed to do with the slope formula? Let's just plug and chug. I do y2 minus y1, and then I divide by x2 minus x1, but x2 is x1, isn't it? So this is x1 over x1. So what do we get? We get y2 minus y1 all over what? 0. If I subtract something from itself, I get 0. So we run into a bit of a problem with the vertical line, don't we? The gist of it is there is rise, but there's no run. So how do I say something, how do I quantify that this thing is going up and down? Well, there's no number to describe how steep this is because it's not really a slope, is it? It's a wall, I guess, if you want to think about it that way. So we don't have a good way of describing that steepness, and we definitely don't have a good way of describing this number. This number is what we call undefined. And there's a very good reason why dividing by 0 we get undefined. Take, for example, the function or the equation y equals 1 over x, and look at its graph. The graph of y equals 1 over x looks like this and like this. So you might say, well, I can define dividing by 0. I can define dividing by 0 as if I just keep going along this and I see where it's going to. It looks like it's going up to infinity, right? So why don't we just say, well, if I divide by 0, I get infinity, right? What's the problem here? The problem here is I can do the same thing from the opposite direction and say, well, I'll just march along until I get to 0 and see what this number is going to. But what is the bottom number going to? Minus infinity, right? So it turns out dividing by 0 can give us infinity, it could give us negative infinity, or also it could give us literally any real number that we want to choose. So that's why we say it's undefined, or it's poorly defined, or we're unable to define it uniquely. So that is why we call it undefined, if you care to know. But what you need to know for like the purpose of an exam is that, okay, how do I graph a vertical line? What is the slope of a vertical line? Undefined. And what is the equation of a vertical line? What is the equation of a vertical line? Well, you can tell that all of the points along this line share one thing in common. What is it? They all have the same x value, right? Which means that x is going to be equal to some number, c, where c is a real number. Okay, x is equal to c is going to be the form of this guy. Okay, so for example, we could have x is equal to 3, is kind of what this looks like, maybe. So here's 1, here's 2, and here's 3. And this is the line x equals 3. Okay, so we say x equals 3 because the x value has to be 3. But the y value can be whatever it wants. So we don't make any mention of y in this equation because it doesn't matter what y is. Y can just be what it wants to be. Okay? Any questions on the vertical line? Okay, it doesn't seem like there's any questions, so we'll move on and talk about horizontal lines next. So a horizontal line, well, we already did the vertical one, which goes up and down. The horizontal one goes left and right. Okay, so this is a horizontal line. So if we take 2 points on a horizontal line, what's the same? The y value, right? So this one is x1, y1, and then this other one we would call x2 because it's a different x value. But it's the same y value, so I'm going to rewrite y1. Okay, so how do I figure out the slope? I use the formula again. M is equal to y1 minus y1 divided by x2 minus x1. Now is the denominator going to be 0? No, the numerator is going to be 0. Is 0 divided by some other number defined? Yes, it is. It's just 0, right? If I have 0 slices of pizza and I distribute them to all of my 3 friends, how much pizza does each friend get? still 0. It is logically consistent, right? I can divide 0 by another number. It's just 0. So this is 0. So the slope of a horizontal line is 0, which makes sense. We're all run, no rise. Okay, so that's the slope of a horizontal line. And how about the form? Well, in this case, what can be whatever it wants? The x value can be whatever it wants. But the y value has to be whatever that number is, right? So this could be y equals to c, where c is a real number. So here's y equals 3, y equals 2, y equals 1, y equals -1, y equals -5, and so on and so forth, right? It just determines the height of the vertical line. I mean the horizontal line, excuse me. Okay, so that's vertical and horizontal lines. Any questions over those two? I think the thing that I notice students getting confused the most with vertical lines and horizontal lines is which one has slope 0 and which one has slope undefined. Okay, so the horizontal line has slope 0. It's easiest to think about in terms of, well, what's the rise over the run? In the vertical line, we have no run. In the horizontal line, we have no rise. That's how I like to think about it. Okay, so let's move on and talk about point slope form. So now that we have discussed horizontal and vertical lines, let's talk about lines which are somewhere in between the two. Namely, they go diagonally in some capacity. So maybe something like one of these lines, okay? So lines that go diagonally, their equation is going to be a little more complicated than these two, because these two are just x equals c or y equals c. But if we have a diagonal line here, then we're going to have to involve both y and x in our equation. So let's see the first way that we do that. So the first way is called point slope form. And the reason that I teach point slope form before slope intercept form is because point slope form is more important. And it's used more often, I would say. So having a good understanding of point slope form will be crucial for not just for our class, but also for if you move on to calculus. So I want to make sure that I prepare you as well as I can if you're going to go into a calculus course, and point slope form will definitely be taken for granted in the calculus class. So let's discuss. So let's say we have a point on the line, x1, y1, and the slope, m, of that line. Okay, so what do they tell me? They tell me one point in space that the line is going to pass through that point. And they tell me the angle with which it is passing through that point, or the steepness with which it is passing through that point. And with those two pieces of information, I can uniquely determine the equation of a line in the following way. I take y minus the y value of the point that it passes through, and I multiply that, or I set that equal to m times x minus the x value of that point. Okay, so all I do is I take the x value, the y value, and the m value, and I plug them into this equation. So one thing that I think is really confusing when you first see this kind of expression is to understand the difference between what is a constant here and what is a variable. So let's label the constants. y1, x1, and what else? What's the other constant? The slope, m. So these are constants. And the variables are, of course, your y and your x, which means we are not going to plug anything in for y or x. Okay, we're not going to plug anything in for x or y. We are just going to take the information from the problem and we're going to fill it in for the constants. Oops, the y1 goes here, the x1 goes here, and the m goes here, okay? So the difference between a variable and a constant in this equation is to say that if we're going to use it, we need to determine what these numbers are first, okay? And those are going to be a fixed number that doesn't change throughout the course of the problem. But x and y are free to change as they will, as long as they continue to satisfy this equation. Okay, so that's the difference between constants and variables. So let's see an example of how we would use this. Okay, so in this example problem, we are given, I'll leave this up on the screen so that you can see it for a little while longer. Okay, so given 2 points on the line, hang on, didn't they say that in the previous thing they said we can find the equation of the line as long as we know 1 point and the slope. But now all of a sudden they're saying they want us to find the equation of the line, and instead of a point and a slope, they give us 2 points. How am I going to handle that? I can find the slope first using the methodology which we described in class last time. Okay, so namely, I can take this one to be x1, y1. And I can take this one to be x2, y2. And then I can find the slope by taking y2 minus y1 divided by x2 minus x1, which is 7 minus 1 divided by 3 minus negative 2, which is 6 divided by 5. Right, because we subtract negative 2 from 3, so that becomes 5. 7 minus 1 is 6. Okay, so this is our slope. Okay, so now all I'm going to do is I have a point. In fact, it doesn't matter whether I pick this point or this point. Both of them are okay. But I'm going to just pick this point because I already labeled it as x1, y1, and x1, y1 are here in my point slope form. So all I'm going to do from here is plug. The first thing I write is y, because y is a variable, not a constant. Now comes a minus sign. And what am I going to put here? 1. I'm going to put 1 here because that's what y1 is. Okay, now an equal sign. Then what? 6/5. And then a parentheses sign. And then what? X plus 2. Why plus and not minus? Because I'm subtracting x1, and x1 is a negative number. If I subtract a negative number, that's the same as adding a positive number. So that's why I wrote plus. Okay, so this is the equation of a line in point slope form. Okay, so the problem that I see a lot of students run into on quizzes and tests or on homework is that they do not memorize this formula. And so they don't know how to, I mean, they know generally that there's a formula and you just plug it in, and they know how to find the slope, and they know how to find the point that it goes through, but they don't remember the formula. Okay, so I would recommend maybe writing this on a flashcard or on the back of your hand, or I don't know, wherever else you might write something, and just look at it once a day and keep it fresh in your mind. Because yeah, it'll be well worth your time, especially if you're going to go take calculus. Any questions on point slope? Yeah.
On a quiz or an exam, would you want us to stop here or go into the next plus B? Or would you say that in the question, I guess?
Yeah, I'd probably specify that in the question. So the question is, on a quiz or a test, can I leave my final answer in point slope form? In general, I would say the answer is, for the most part, yes. I don't mind if you give us the equation of a line in point slope form. Now, if I give you directions and the directions say, please translate this equation of this line, which is in point slope form, to slope intercept form, then, I would ask you to do that explicitly. But yeah, generally, for the most part, I'm pretty forgiving with answers as long as your answer is equivalent to the correct answer. So, point slope form is arguably better than slope-intercept form in terms of being able to see what this line looks like. So, yeah, I would say it's fine to leave it like that. But I'll always specify otherwise in the instructions. And if I don't specify, then you can come to office hours and say, I can't believe you marked me wrong. You didn't specify that we were supposed to do this. And I'll say, oh, yeah, you're right. And I'll give you points back. Okay, any other questions about point slope form? All right, doesn't seem like it. Got plenty of time. All right. So now let's talk about the one that probably people are more familiar with, which is slope-intercept form. At least when I was growing up, this was much more emphasized for some reason. I don't know why. But here's how it works. So if this is the equation of our line, this is a line. So again, let's look at our constants here. So these m and b are going to be constants. Okay, m and b are going to be constants. So for example, they could be real numbers. And this equation is going to be the equation of a line with slope m passing through 0, comma b. And we call this the y-intercept. Okay, so basically the m describes the slope and the b describes the point on the y-axis that the line passes through, okay? Now a point on the y-axis is entirely defined by its y value because they're all something like 0, 1, 0, 2, 0, 3, right? Those are all of the values, or all of the points which are on the y-axis. So the y-axis height is always determined by just a single number, which is going to be this b value. So let's do a quick graph of y equals 2/3 plus 2. 2/3 x plus 2. So we know that the line, passes through this point, 0, comma 2. And it has slope 2/3. How do I do a slope 2/3 if I'm going to try to draw a picture here? How do I handle something like that?
You go up 2 units and go over there.
Exactly. So I'm not going to try to go up 2/3 and over 1. Okay, I'm not going to try to go up 2/3 and over 1. I'm going to try to go up 2 and over 3, because that's the rise over the run. So rise over run. So I'm going to go up 2 and then over 1, 2, 3. And that's where I'm going to put my next point. As soon as I have 2 points on this line, then to draw the rest of the line, all I have to do is draw a line which goes through them. Okay? Because a line will basically be pinned down by any 2 points that you pick. There's no other lines that pass through these 2 points. It's just the one. Okay. So that's slope-intercept form. Any questions on that one? Is that pretty familiar to you all? Slope-intercept form, y equals mx plus b? Okay, cool. Then let's move on and talk about the dumbest one, which is general form. And the reason I say it's dumb is because no one ever uses it, and it makes very little sense to arrange a line like this, but if you want to, you can. So actually, they require, or do they require? Let me think about that for a minute. I suppose that's not really possible, is it? Okay. Yeah, that's not possible, because then you can't do some of the lines. We'll keep it as r for now. Okay, so what do we have? We have ax plus by plus c, where our our variables are, of course, x and y, and our constants are a, b, and c. And one of the points that is kind of a sticking point of the general form, if I remember correctly, is that they actually want a, b, and c to be whole numbers, if you can. Now, that can only really be done as long as the coefficients of x, y, and our constant are rational numbers, because then you could just multiply everything by the LCD, right? The least common denominator. But if you had something like a equals the square root of 2, I don't think you'd be able to, you won't be able to find a, yeah, okay. Sorry, this is not really important for you, but it's bothering me. So I'll just move on. So yeah, a, b, and c should be real numbers. Okay, so we take a number times x plus a number times y plus a number is equal to 0, right? And the way I would rearrange this to get, say, slope-intercept form is I do, okay, by equals negative ax minus c, and then I divide both sides by b, and I'd get y equals negative ax minus c all over b, right? That would be how I would get this thing into slope-intercept form, because this, of course, would just be negative a over b x minus c over b. So then this would be our slope, and this would be our intercept. But of course, as you can see, this isn't really helpful for if you wanted to, say, graph this equation. But I just wanted to make you aware of it. There may be some problems on the homework or something where you have to convert from general form to point-slope form, or from general form to slope-intercept form, or something like that. Okay. Any questions on general form? All right, it doesn't seem like there's any questions on general form. So let's talk about parallel and perpendicular lines. Okay, so you may already know that if we have a coordinate plane, and we have two lines in the coordinate plane, other than the axes, obviously. If I have two lines in the coordinate plane, then they can be, then one of three things happens. The first thing that can happen is two lines never meet, meaning that the two lines go on and on forever in the same direction. Okay, the second thing that can happen is that the lines meet once. So that would look like something like this, maybe. And then the third thing that can happen is that the lines are the same, or they intersect infinitely many times. Namely, here is line 1, and line 2 is literally like on top of it. Okay? So if we have two lines which are literally on top of one another, then they intersect infinitely many times. So the only way that we can have condition 1 be true, namely that the two of these lines never meet one another, is if they are initially a certain distance apart and they go in the exact same direction, right? If they go in the same exact direction, then they won't get any closer together and they won't get any further apart, right? So this is what it means for two lines to be parallel. So two lines are called parallel if the slope of each line is the same. Okay, so for example, y equals negative 3x plus 2, and y equals negative 3x minus 71. Okay, so these two lines look like the following. Negative 3x plus 2 looks like this. Negative 3x minus 71 is probably way off the bottom of our screen, but I'll put it like that. Okay, looks something like that. Okay, so these are what parallel lines look like. They go in the same direction, and that means that they have the same slope. Okay, so that's parallel lines. And of course, we also have the other kind of lines, which is perpendicular. Now, perpendicular means the following. It means that the two lines that we have meet and cross each other exactly one time. But more than that, we also require that they meet at a specific angle. Namely, it should be a right angle. Okay, it should be a right angle. So this is 90 degrees. Okay, so two lines are going to meet each other at a right angle if this thing is true. Okay, and this is a little bit confusing, but it's the better way of putting it. The slope of the first one times the slope of the second one should be equal to -1. In other words, if we wanted to say, well, I know the slope of the first one, what should the slope of the second line be? Then we could say, rearrange this so that m2 is equal to -1 over m1. In other words, it's the negative reciprocal. Slope. So for example, we could have y equals -3x plus 2, and then y equals, well, what do I need to do? I need to take -1 and divide it by -3, right? If I do that, I get 1 over 3. And then, I don't know, plus 7. Okay, so here is an example of a line which is perpendicular to the first one. What needs to be true is that the slope of the first one and the slope of the second one, if I multiply those two together, I get -1. Okay, -3 times positive 1/3, I get -1, right? I'm hearing a lot of shuffling. We got a little while still before the quiz. We're just turning the page, maybe. Okay. So that's perpendicular lines. Okay, maybe you're shuffling because you're about to try with a partner. Okay. All right, so let's try with a partner. Okay. Our goal here is to take two lines. I've given one line in terms of point slope form, and I've given another line in terms of general form, the stupid one. And we're supposed to determine, are they parallel, perpendicular, or neither? Okay, we're supposed to determine whether they are parallel, perpendicular, or neither. So why don't you try that with a partner? I'll leave the definitions up on the screen, and if you need a little bit of help, then call me over and I'll try to help your group, okay? So go ahead and get started.
Like, since this is like y, it's like this is y. Is y equal to b? So what you're doing is like changing y.
One second. Let me really quickly. I'm gonna move the definitions. Is that okay? Because I want it to be bigger so that you can all see what these are. Is that better? Yeah. Okay. Okay. So what's the question?
Okay, so how do we change, so that's just, so that's the general. How do we change that again? I'm not sure. You're fine, so.
Okay, so if we start with this, right? So what do we need to understand in order to understand whether the two lines are parallel?
They are.
We need the slope of the
Yeah.
first one, right?
Oh, wait.
So we already know what the slope of the first one is, right? What is the slope of the first one? It's just 2, right?
I don't think they
In
are.
fact, you don't even actually have to convert it.
I don't know why I converted this. I just thought it was easier.
Yeah, that's fine. If it helps you to convert, then you're always welcome.
Where'd you get the
Okay, so x plus 2y plus 6 equals 0. What do we do to go from here to here?
So you wanted
We isolated y, right?
Yeah.
We can do the same process with this one, right? So let's go ahead and do that. Let's isolate y. How do we do that?
And then we like just do negatives on y.
And then you get y.
Okay, and now y is y by itself?
When you go y equals -2.
What divides by?
Then you add
So
5.
divide everything by
Exactly.
And then.
So now what do I get?
So then this general.
We divide by -2, we get x over
You get 2y equals negative x minus 6 divided by 2. And you get y equals -1/2 x minus.
So they're all.
Right, because what is the slope here? We
Yeah,
can
so
rewrite
you would need
x
for it to be
divided by
perpendicular to
-2
be
is the
inverted
same as
positive
negative
to x.
1/2 times x.
That would be perpendicular, because they're not negative, it's not negative. You got the answer?
Okay, so one is 2, and 2 is negative 1/2.
Yeah.
Which times negative 1/2?
And then on parallel, it's not so bad.
Divide that by 1 times 2, which is 2, and negative 2 divided by 2 is negative 1. So I think we're almost there. It's just that you need to apply the same thing that you did over here. I dropped it too low.
Ours is from like, oh. Hey, at least I didn't fall down there. How about
I'm not worried about
if you can watch it,
Oh, wait, like,
He does not take it.
no, like,
Does anyone need a little more time to work? Okay, I don't see any hands up, so let's talk about it together. Okay, so our goal was to determine whether these two lines are parallel, perpendicular, or neither. And what is the only thing that matters about these two lines? In order to figure that out, I heard it already, it's the slope. The only thing we need to know is the slope. The first one, I can immediately identify what the slope is, can't I? What is M1 going to be? -2, right? -2. Okay, I think we might have written it down over there. Wrong, Piper. Because we got 2, didn't we? Or was that for the other one?
We got 2.
Oh, I think it was just a copy error, that's all. Okay, so we get -2 here. Okay, now how about the other one? It's not immediately clear what the slope is for the other one. But how can I figure it out?
I just rewrote it.
I can rewrite it. For example, I could get it into slope-intercept form by solving for y. Okay, so let's do that. If I solve for y here, I'm going to move x and 6 over to the other side. I'll have 2y equals to -x minus 6. Agree? And then I just divide both sides by 2, so I get y is equal to, what? -1/2. Okay, hang on. Let me write it in a different way first, but we're going to go there. I'm going to do -x over 2, and then minus, okay, 6 divided by 2, we get 3. So the reason I wrote it like this is because sometimes it can be a little bit tricky to see what is the slope of this line when x is like in the numerator of a fraction or something like that. But what I want to remind you all is that we can always rewrite this as multiplication. So I can rewrite -x over 2. Okay, that's like dividing by -2. So I can rewrite it as multiplication by -1/2. Okay, and then I have a -3. So it looks like, in this case, M2 is equal to -1/2. Did everyone get the same result? Okay, so M1 and M2 are -2 and -1/2 respectively. So what do we think? Do we think parallel? No, not parallel, right? Because for them to be parallel, what would need to be true? They'd have to be the same, and they're not the same, are they? Okay, how about perpendicular? Do we think perpendicular? I'm hearing no's. Why not perpendicular? This one's the reciprocal of the other one.
One has to be positive.
That's right. One has to be the negative reciprocal of the other. So it's not perpendicular either. So I guess we're left with the final option, neither. Okay. So do we feel a little better about perpendicular and parallel lines after that example? Okay, cool. Then let's move on to a harder problem, which I'll guide us through. Not that I don't think you could do it. I think you could definitely do it. But for time's sake, I'm going to do it. So the other type of problem that we see a lot of the time is, okay, we need to find a line which is parallel to another line or perpendicular to another line. So maybe we'll do both, actually. We'll do parallel first. So the first thing I want to do is find the equation of a line which is parallel to this line. So what needs to be true about our new line in order for it to be parallel to this one? The slope needs to be 3. Okay, so you know what we could do is literally we could write the same line over again, right? Why? Because every line is parallel to itself. Namely, it has the same slope. But if you wanted to pick a different one, then all you'd have to do is change up one of these numbers, maybe like y plus 2 or something like that. Because remember, the only thing that matters is that the slope should be the same. We don't care about the point that it passes through. So this one passes through the point negative 3, 2, and this one passes through the point negative 2, 2. Okay, so parallel lines, pretty easy. What if we did a perpendicular one? Let's also do a perpendicular. What would we want the slope to be of a perpendicular line? We would want m2 to be negative 1/3. Right, negative 1/3. So I could do the equation maybe y plus 3 equals to negative 1/3 x minus 2. Then that would be the equation of a perpendicular line which passes through the same point that our other line passes through. And that's the location of the cross. Okay. Any questions about that example? I think it's trickier when it's in general form, and then you got to find the slope, and then you got to make it a reciprocal and stuff like that. So there's really not that much to that kind of a problem. Any questions on it, nonetheless? Okay, doesn't seem like there are. So let's talk about finding the intercepts. Okay, so this is not something new. This is actually a callback to one of our previous lectures. So there were two types of intercepts that we could have. One of them was the so-called x-intercepts. And x-intercepts are where the graph crosses the blank axis. What goes in my blank? An x-intercept is where the graph crosses the x-axis. Now, if I cross the x-axis, what is the form of my point going to be? Okay, the question is too vague. What do I know is the same for every point on the x-axis? The y value is 0. That's a more specific question. So we know that if we're on the x-axis, then y is equal to 0. So all I'm going to do is I'm going to plug y equals to 0 in, and I get negative 5x equals 10, because this term goes away. 2 times 0 is 0. And now what happens to x? X is just going to be equal to -2, right? Okay, then let's do the y-intercepts. Well, I'll do that with this lavender color maybe. Y-intercepts are where the graph crosses the y-axis now. What thing do every point on, my God, my English. What does every point on the y-axis have in common with one another? They have the same x value, namely 0, right? If we're on the y-axis, then this tells us that x is equal to 0. So I'm going to plug in x is equal to 0 above. And I'm going to get 2y equals 10. And then I will solve for y equals 5. So my intercepts are -2, 0 for the x-intercept and 0, 5 for the y-intercept. And the useful thing about finding these intercepts, okay. No, I want the other one. The useful thing about finding these intercepts is that now we can do a graph of this equation. So I didn't even have to translate this into slope-intercept form or point-slope form. All I did was plug in 0 for x, and then I plugged in 0 for y. I got 2 points on the line. 2 points is enough to make our graph. So how about we put a point at -2, 0, that's right here. And I'm going to put a point at 0, 5. So 1, 2, 3, 4, 5. Here's another point. And I can go ahead and graph because 2 points define a line. So that is how we find the intercept of a line. And this one happened to be in general form. And we could find the intercepts, no problem. We did not need to convert or anything. We just needed to remember that lesson from a few days ago where we learned how to plug in to find the intercepts. So just a quick reminder, to find the x-intercepts, we plug in what? 0 for y. To find x-intercepts, we plug in 0 for y. To find the y-intercepts, we plug in 0 for x. Okay, so that's the confusing thing about those ones. Any questions on this? Okay, if no questions, then we can do the quiz. So please put everything away except for a pencil.
Oh, we need paper this time.
Hang on. Okay, please pass these down the line, but leave them face down on the desk in front of you, please. Also, I'd like everyone to put their devices away in their book bag, including any wearable devices such as an Apple Watch, or an Apple ankle watch, or anything else. Please lay them face down on the desk in front of you. Okay, please continue to wait until everyone has a quiz. We're still passing. One more? Okay, there should be an extra from the line behind you.
It's just the anticipation of seeing.
Yeah.
Sorry, I don't mean to stress you out.
Wait, my math lab won't let me like go back and look at the homework, so.
I'll show you how to do it after class. There is a way to do it.
Minutes to try and figure it out.
Yeah, it's
Yeah,
it's
I
weird
emailed
how
you.
hard it
I
is.
emailed you and then immediately 2 minutes later I went back to like until you answered me. I was like gonna try and still find it. And
Yeah.
I literally immediately.
I had a couple students
Like, uh-oh.
have problems with that. Okay, does everyone have a quiz now?
It's like, you have to really hurry.
Okay, go ahead and begin. Good luck. You can go ahead and silence that. That's okay.